Salut! Firstly, we will learn the fundamentals of index laws. Afterwards, we can interpret and analyze algebraic expressions. Consider the base of 5. If I raise 5 to the power of 2, you'd know the answer straight away, and that would be equal to 25. But let's first understand what this means. The number 5 would be read as the base. The power of 2 would be called either the index, power, also known as exponent. It's best if you know these terms moving forward with the context. I will now generalize this term in order to understand all the laws of indices. I'm going to consider a base called a raised to the power of p. I would now multiply a to the power of p with a different index. Base would stay the same, and I'm going to change the power to q. We can simplify this because we have the same base with multiplication in between. Your result would be a to the power of p plus q. This is known as the multiplication law. To understand the second law, I would consider the same base and the power, that will be a to the power of p. This time we have division instead of multiplication, and again I would repeat a to the power of q. With the same base and division in between, the powers would subtract. Hence we have a to the power of p minus q. Remember, multiplication means you need to add your powers, and division means you need to subtract your powers. And this is called the division law. For the third law, I'm going to consider a to the power p. I'm going to use a bracket, and then q would also be a power. This would lead to the multiplication of powers. Hence I have a to the power of p multiplied by q. And this is called the power law. For the next law, I'm going to consider a to the power of p divided by q. Remember, p over q is a fraction, and you need to understand that p and q are integers. Hence we call it a rational number overall. The result of this would be a to the power of p, and we need to take the root of q, or we call it the qth root. For our next law, I'm going to consider a negative power. Let's assume a to the power of negative p. This is also known as taking the reciprocal of the given term, hence the power becomes positive. For the next law, I'm going to consider a base to the power of 0, and this would be always equal to 1. But also note that a in this case, that is your base, cannot be equal to 0. We will now apply the laws of indices into applications. We need to follow the order of operations in order to simplify the following algebraic expression. Firstly, I will expand the terms inside the bracket. 4 to the power of 3 multiplied by y to the power of 3 multiplied by 3. As you can see, I have used the power of 3 outside the bracket to both terms inside the bracket. The common denominator will be 2y to the power of 3. I will now simplify the numerator. 4 to the power of 3 would be equal to 64 multiplied by y to the power of 3 multiplied by 3 would be 9 divided by 2y to the power of 3. I will now consider the like terms, which means I have 64 divided by 2 and y to the power of 9 divided by y to the power of 3. 64 divided by 2 would be equal to 32. I will now apply the division law in order to simplify the base of y. Y to the power of 9 minus 3, and that will be 32 y to the power of 6. This is your answer. I have considered the fraction given, and that is 2 minus root x within brackets to the power of 2 divided by root x. Firstly, I would expand the numerator. I would then have 4 minus 4 root x, and then I need to square negative root x, which gives me positive x, divided by the common denominator of root x. I can now divide the three terms separately, which means I have 4 over root x minus 4 root x over root x, and the third term would be plus x divided by root x. This will be equal to 4 over root x means I have x to the power of half, and minus 4 because root x and root x cancels off, and then I have x to the power of 1 over x to the power of half. Reciprocal for the first term, which means I have 4 x to the power of negative half minus 4, and then I can apply the division law for the third term, which means I have plus x to the power of 1 minus half. The final answer should be equivalent to the expression they have given here, and that will be 4x to the power of negative half minus 4. For the last term, we have x to the power of 1 minus half, which means I'm left with x to the power of half. This is the answer. In this question, our goal would be to find the value of p. 343 can be written as a base of 7, and that will be 7 to the power of 3. And then we have root 7, which means multiplied by 7 to the power of half. And the RHS will not change. I would have 7 to the power of p. I will now simplify the LHS by using the multiplication law. 7 to the power of 3 plus half. And the RHS would not change. For the next step, we have 7 to the power of 7 over 2 equals 7 to the power of p. In order to proceed, I will use the theory given here, which states that when bases are the same, the powers should also be equal. As you can see, the bases are the same, which is 7, and which means powers should be equal. Hence, the solution for p would be 7 over 2. This is your answer. In this question, I will build up an equation. 27 to the power of 2x plus 1 equals to 3 to the power of p. Remember, 27 as a base of 3 would be 3 to the power of 3, and it already has a power which is 2x plus 1. The RHS would not change, which means I have 3 to the power of p. For our next step, I will use the same condition we have used in the previous example. If bases are the same, then powers can be equated. I have 3 as the base on the LHS and 3 as the base on the RHS. Hence, I can equate 3 to x plus 1 equals to p. Hence, p would be equal to 6x plus 3. This is your answer.